Hi, I'm going to work out a statistics problem here, and the statistics problem is a random sample of size 200 is drawn from a continuous population Y. It is known that and this U sub Y is the mean of all values of the sample mean is equal to 58, and the standard deviation with the little subscript y is the standard deviation of all values of the sample mean is equal to 17. What is the expected value of y? Do not use any decimal points in your answer. So I'm going to answer a few of these questions and then I'll go through a few more. So the first one says, let me pull my pen up here. What is the expected value of y? So the expected value in any distribution like this is going to be the same as the mean. So in this case, the expected value, which we can denote with an uppercase E, is just going to be equal to our mean of our sample means, which, let me write that a little bit better. Our mean of our sample means, which in this case is just equal to 58. All right, now what is the standard error? So let me write that out. What is the standard error? To find the standard error, what we're going to end up doing is, just one moment. Sorry. To find the standard error, what we're going to do is we are going to take the standard deviation of all of the sample means, which is 17, and then we're going to divide that by the square root of our sample size. And that's the formula using the central limit theorem in order to find your standard error there. So it's going to be your, oops, let me get that back here. So it's going to be this value here divided by the square root of our sample size, which in this case is 17 over the square root of 200. And this is approximately equal to 1.20. All right, the next question is, I'm going to write this one out here. What is the probability P, the y mean is greater than 60? All right, so in this next question here, what we're basically asking is, what's the probability that if I take a sample of 200 people, other than this sample, what is the probability that I'm going to get a mean that's greater than 60? Now let's go ahead, and at this point I'd like to draw a little bit of a curve and right down the middle, this is our mean, our y values, and this is equal to 58. And what we're doing is we're saying, what's the probability that the y value of a random sample of 200 people is going to be greater than 60? Well, I'm going to go ahead and put my 60 over on this side because it's to the right of 58. And they're asking about greater than 60. So I'm going to shade in everything greater than 60. So I am trying to find the area of this right tail, and that area should correspond to the probability of my y mean being greater than 60. So in order to do this, I can convert my data value 60 into a z-score, and that's going to look like this. Z is equal to the data value minus my mean all over my standard deviation, and that's going to be 60 minus 58, our mean, all over our standard deviation, which is 1.2. And this is going to be equal to, let me pull up my calculator here. So 60 minus 58, enter, divided by 1.2, enter, and I should get about, I'm going to round this off to 2 decimal places because that's what my table looks like. So this is going to be 1.67. So this is 1.67. And what does this 1.67 mean? Well, that means that this value of 60 is about 1 2/3 standard deviations to the right of my mean. So I can go to my normal standard distribution table, and let me pull that up, which I did not save that from before, I don't think. Alright, so I'm going to pull this up, and I'm going to go to the z-score. Now remember, this probability goes from -infinity to our z-score, so it's only going to be giving us the left side of a distribution. So I'm going to go to 1.67, and I'm going to go to 0.07 here. That's 1.67. I'm going to get 0.9525. So what does that tell me? It tells me that this area here, because remember, it's going the left side, this area, which is all of this area here. So all of that area there is approximately equal to, let me go back to it, 0.9525. So 0.9525. However, we're looking for this other area, the smaller area to the right here, because our problem is a greater than. So in order to find this area, remember the entire area adds up to 1. So if I take 1 minus the area that I just found, 0.9525, I'm going to get, well, let's pull up the calculator. So 1 minus 0.9525, that's equal to 0.0475. 0.0475. And that's going to be my answer down here. So the probability, and you convert that to a percentage, that's almost 5%. So there's about a 5%, 5 out of 100 chance that that I'm going to get a mean that's greater than 60. So let me go ahead and write it down. It's hard to write. 0.0475. All right. Now the next question that we're going to ask is, okay, what is the probability one mean is less than 58.5? So now we want to know what is the probability that this is less than 58.5. So using the same normal distribution curve that I did before, I'm going to just start it off the same here. So the mean is 58. And then I'm going to go ahead and mark the 58.5, which should be just a little bit to the left of it. And I'll kind of put a little note here that that's 58.5. And they are asking for the area to the less than that. So this is going to be all of this area. Now, one thing I like to note is for a lot of these problems is what approximately am I going to get? I know that if 58 is the average value, then the area under 58 is going to be 0.5 because it's exactly half of my total area of 1. So this value here is just a little bit over 58. So I include that entire 0.5 plus this little portion here, which should bring me over 0.5. So I should be expecting a value somewhere between about 0.5 and 0.6, maybe even up to 0.7. But to get an idea of what we should expect definitely will help us with any wrong answers at the end. So we're going to do the same thing we did before. I'm going to go ahead and convert this to a z-score so I can use my standard normal distribution. X minus mean over the standard deviation, which is, this time it's going to be 58.5 minus 58 all over 1.2. And this should give us, let's go ahead and pull up the calculator, 58.5 minus 58 divided by 1.2. This gives us, that rounds to 0.42, 0.42. So 0.42. Now let's go ahead and pull up my chart. And it's going to be 0.42, so that's 0.6628. So this is going to be 0.6628. And that seems about right. It's a little bit more than half. So that's our answer. So there's about a 66% chance, about a 2/3 chance that our mean will be less than 58.5. All right, and that should be the end of this question. And I hope you have a great rest of your day. Thanks.